Hello guys, welcome to a new video. This is Physics 2 class and this week we will investigate about the universe, okay? But first, our value for August, okay? Self-esteem. So as a definition, self-esteem is the judgment or opinion we hold about ourselves and it's the extent to which we perceive ourselves to be worthwhile and capable human beings. Okay, self-esteem is the picture we have of ourselves. Remember to practice this important value and build your positive self-esteem. Okay, so continue with the topic. The universe matter is not homogeneously distributed, but the contrary is that concentrated in certain areas forming galaxies, which form large groups called galaxy clusters. Among these areas there are just voids or empty spaces. Okay, this is an example of empty space. There are galaxy. This is a galaxy cluster, and this is a Milky Way. Okay, so a galaxy is a large group of stars between 100,000 and 500 million towards the center of the galaxy. The stars are close together, okay? An enormous cloud of gas and dust are nebula, called nebula, surrounds the stars, okay? The stars, okay, are made up mainly of hydrogen and helium, the two most abundant gases in the universe. Inside them, there are nuclear reactions which produce huge amounts of energy, and they are so hot inside that they emit heat and light. Okay, and within a galaxy, we can find groups of stars relatively close to each other's. Okay, and they are open cluster. So this is an example of different galaxy in the universe. And the structure of galaxy, inside the galaxy we can find the following structures. Okay, billion of stars, because star clusters they are groupings of stars held together by gravity. The nebula they consist of clouds of gas, mainly H and He, and stellar dust. These are the places where stars are born. Also, they can be the remains of the star that died. Example, pillars of creation in the Eagle Nebula, 7,000 light years away. A multiple stellar system that they are two more or more stars held together by gravity that revolve around a common center. Okay, and they are often apparently seen as a single star, but they are commonly double of binary systems. For example, Alpha Centauri, the nearest star to our sun, and is a binary system. Okay, and this is the structure of galaxy. Continue. Many stars Many stars have planets that revolve around them, forming planetary system, like our solar system. So planetary system they consist of a central star which have other bodies orbiting around it. Okay, and planets are bodies which orbit some stars. They don't emit light. They receive light from the star and reflects it. Okay, the star is this one. That's why we can see them. So planets, some planets have satellites or moons. They are small bodies that orbit a planet. The Earth's natural satellite is the moon. Okay. So the type of galaxy we have elliptical galaxy, irregular galaxy, spiral galaxy, and bar spiral galaxy. Okay, elliptical galaxy, these galaxies have a little nut to structure. They are rich in all stars and have little gas and dust. They are the most common type of galaxy, okay? And it's believed that the large ones come from collision and merging of other galaxies. Irregular galaxy, okay, they look chaotic, they have no nucleus, and they are considered to be the result of collision of galaxy. So they contains a mixture of interstellar gas and dust, all stars and young stars. Okay, continue with the spiral galaxies. These galaxies are disc-shaped, either a round central hub or a hub shaped like a bar. Gas clouds and young stars are arranged in the spiral arms, and all stars from the halo surrounding the central disk. And Bird-Spire Galaxy in the central, there is an axis from longitudinal bar. Okay, so like example of the Via Láctea, and this is the type of galaxies. Our galaxy is an spiral-shaped galaxy called the Milky Way. The Milky Way belongs to the galaxy cluster called the local group. Okay, the local group. And the local group is made up about 33 galaxies, and the closest galaxy that to us is Andromeda. Okay, so this is an example. This is the local group, and here we are, the Via Láctea on Milky Way. And the type of galaxy, as I said, spiral, irregular, spiral, peculiar, elliptical, and lenticular. Galaxy and galaxy cluster and supercluster. Galaxies are made up of billions of stars, gas and dust clouds and dark matter gravitationally bound. There are of over 100 million galaxies in the observable universe. They are planet ellipsoid shaped and with a tracer area in the core. Our galaxy, the Milky Way, is about 10,000 light years in diameter, and the nearest star to our sun is Alpha Centauri. So galaxies move in the space are grouped to form the so-called galaxy clusters, which in turn may form larger aggregates called superclusters that may contain thousands of galaxies. For example, the Milky Way is part of the local group, a galaxy cluster comprising 30 galaxies, of which Andromeda is the nearest galaxy to us. So the local group in turn orbits around the large cluster of galaxies called Virgo. The Virgo cluster, along with the local group and other clusters from the local supercluster, all these clusters are moving in the same direction, although the reason is not yet known. Okay. The universe composition, we have three: ordinary matter, and dark energy. Okay, ordinary matter or baryonic matter, which can be visible and invisible. Visible, like a star, planets, intergalactic hot gas. Okay, invisible is black holes, intergalactic gas. Okay, ordinary matter is made up of atoms. The chemical elements of the periodic table consist of protons, neutrons, and electrons. Around 70 and 75% of this matter is hydrogen, the simplest element. About 25% is helium, and there are small amounts of the other 108 elements of the periodic table. It emits or reflects light so that we can detect radiation coming from it, with exceptions, and it has gravitational effects. From dark matter, its composition is unknown. It's assumed that the dark matter is composed of a type of particle that has not been found in a laboratory yet, and it doesn't emit or reflect light. So we don't receive any radiation from it, and its existence is inferred from the gravitational effects of rotational speed of galaxy and inside the galaxy cluster, and also from mathematical predictions of total mass of the universe. And last one, dark energy is unknown. It's a homogeneously distributed throughout the universe and has opposite effects to gravity. So it's thought to probably causing the universe expansion to accelerate. Okay, this is the universe composition. And how do we know that there must be dark matter in the universe? So dark matter was proposed by astrophysics due to the discrepancies between the mass of large astronomical objects determined from their gravitational effects. So, and the mass calculated from the luminous matter, they contain star, gas, and dust. So stars in galaxy rotate too fast according to the visible mass enclosed in its orbit. So they should be thrown out unless galaxy had more mass. So that's why it's dark matter. They attracted them, okay? And calculating mass from visible matter is not enough to hold together the galaxy that form the cluster. So they should move away unless there were more mass dark matter and it's closer to keep them together, okay? So methods to study the universe. We have the first one that is analysis of the matter that comes from outer space. Okay. The second one is analysis of the radiation that come to us, light and radiation like radio waves, infrared radiation, etc., detected by telescopes and radio telescope, both terrestrial and space ones. And the third one, analysis of the images and data obtained by satellites and space probes, devices that are sent into space to do research work and don't return. The origin of the universe, the Big Bang. The universe is expanding that implies that if you go back in time, galaxy were getting closer and the universe was smaller and smaller. Finally, the conclusion is that the universe originated from a single point, okay? Primordial atom that is giant explosion called Big Bang. This Big Bang happened about 15 million years ago. Before the Big Bang, according to scientists, the vastness of the observable universe, including all its matter and radiation, was compressed into a hot, dense mass just a few millimeters away. Sorry, and this almost incomprehensible state has been speculated that exists just a fraction of the first second of time. Massive blast allow all known matter and energy of the universe, including space and time, to arise from some type of a no energy. Okay, so this is all, guys. Thank you for your attention. If you have questions, I can help you. Have a nice week.